Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college live lesson A-level maths year 2 pure maths. We're looking at more trig equations today, inshallah, God willing. Let's take a look at today's example. If you're following through in the book, it's example 11 of chapter 7. Bismillah, in the name of God, the most gracious, the most merciful. This equation is to solve 3 times cos 2x minus cos x plus 2 is equal to 0. And we want that for x to be between 0 and 360. So take a look at the equation and ask yourself, what trig identity can you use to try and simplify it a bit? Here you've got cos x and here you've got cos of 2x. So that's your first problem that you want to try and solve. Can you make them both the same? Can you make them both x really? You don't really want to have 2x in the cos equation or a sine equation. Let's try and use what we know about cos 2x formulas. Remember there's 3 of them. So you've got cos 2x is equal to cos squared minus sine squared. But you don't want to use this one because you're going to end up with the equation having cos and sine. You don't want to have cos and sine unless you make it into tan, but we've already done one of those and this isn't one of those. Cos 2x, let's try another one. We could have cos 2x is equal to 1 minus 2 sine squared x. Okay, we don't want to use that one again because then we're going to end up with a sine in there as well as the cos that's already there from the middle term. So it's the last one we want to use, the third one. It's cos 2x is equal to 2 cos squared x minus 1. So let's take the 3 a little bit to the front. Let's put brackets around the cos 2x. And then what we can do is we can swap the whole of the cos 2x with the whole of this 2 cos squared x minus 1. So the first two we can get rid of, but then this third one, that's the one we want. And we just want to put that within the brackets here. So this can go in place of the cos 2x. Okay, that's good now because now we've got cos x and cos x. This one's got a squared in it, but that's okay. That's better than having the 2x. Okay, let's expand out then. We've got 3 times 2 cos squared. So that's going to be 6 cos squared x. And then I've got 3 times minus 1, which is minus 3. And then the rest is normal. Nothing to be done here. And now you want to just try and get a quadratic so that you've got only 3 terms and it's equal to 0. So the minus 3 plus the 2, that can be combined. Minus 3 plus 2, that's minus 1. So we can replace all of that with minus 1. And this is a quadratic, but it's not a very easy one to look at because of the cos making it a bit difficult. So we can replace the cos for just c. So we can imagine it was a quadratic with where you've got 6c squared minus c minus 1 is equal to 0. And if you factorize that, you'll get 3c plus 1 in one bracket, 2c minus 1 in the other bracket. And from the first bracket, that means that c, which really was cos x, So cos x is equal to minus a third. And from the second bracket, c is equal to a half, but c was really cos x, so cos x is really equal to a half. And then you can just inverse cos them. So if you grab your calculator and inverse cos each answer, and then the easy part is to just inverse cos and you'll get your first answer. But then the harder part is to remember how do you get any answer after that. So 1 divided by 3, that's your minus a third. Let's inverse cos that. So we get one answer which is 109.47. But there is another answer that goes with that, that pairs with that. Try to think how we get that. Let's go on to the next one. Cos x equals a half. So inverse cos of a half. Inverse cos. So that's 60 degrees. So that's a nice easy one. So how do we get the second or the third or the fourth? Because we've got to get a whole range of between 0 and 360. With cos, you just have to make it balance, add to 360. So we've already got 60, so the next angle will be 300. We've already got 109.47, so the next angle will be 350.53. No, sorry, 250.53. Okay, the pairs have to add to 360. If it was sine, it wouldn't add to 360, but we'll come to that when we come to that. So there are your angles between 0 and 360, which satisfy the original equation. Join me for more tomorrow in our next lesson. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.